afternoon and morning? This is Wednesday for academics. So we hopefully you've noticed we've been doing triangles. So we sort of transitioned into our geometry unit, and today we're going to start getting into more shapes. Okay, we will still do triangles, I think tomorrow, but we're going to do like a review of shapes. Y'all have heard some of this stuff from elementary school. Some of this, maybe you know the shape but didn't know the different little characteristics about it. And so today's going to be hopefully a pretty chill day. Okay, so starting with quadrilaterals. Quadrilaterals means, what's special about quadrilaterals? They have how many sides? 4 sides, because the which part says 4? Quad. Okay, 4 quad. So these are all going to be 4-sided shapes that we look at today. So let's see which ones do y'all know. What is this shape right here? This is a trapezoid. Okay, so you can label that trapezoid. Okay, we're going to add some stuff to that, but we'll just put that there. Anyone know what this is called? Parallelogram. Parallelogram. This is a rectangle. This is a and a square. Okay, so we're just going to talk about different unique facts about rhombuses, quadrilaterals. We're going to put little symbols. First, to review, remember how in a triangle, like especially like isosceles and a equilateral, we would do like tick marks, and those tick marks show what? They show congruent sides, equal sides, sides that are the same. Like, y'all good with that? Okay, so we're going to sort of put some of that on here. So we start with quadrilaterals. All of these, I think of this sort of as a family tree. These are all different types of quadrilaterals, okay? And they split off at different reasons for different characteristics, okay? Notice that as it falls under, all of these are quadrilaterals, and so like we'll see that rectangles and rhombuses have the same characteristics as a parallelogram, that kind of stuff. So starting with trapezoids and parallelograms, the difference between the two is in trapezoids, they have one set of parallel lines, and a parallelogram has how many sets of parallel? 2, okay? So the way that we show that shapes are like lines are parallel is with arrows. So on a trapezoid, like in this one specifically, the top and the bottom lines are parallel. So we do a little arrow to show that. Sometimes we'll like fill it in like this. It's more of an arrow. I want to do that. Give me 1 second. Sorry, those triangles are a little bit better. So sometimes we'll use triangles. I will most likely though use just little arrows like this. Okay. For a parallelogram, again, they have 2 sets of parallel sides. So like the top is parallel to the bottom. So I'll go with that. And then the sides are parallel. Now because the side is not parallel to the top and bottom, they then use like 2 arrows to show those 2 sides. Y'all good with that? A triangle would not be in this family tree because a triangle has how many sides? 4. Triangles have 3 sides. This is talking about 4-sided shapes. What if, okay, say your question again. Oh, you sometimes will see it. Most likely it's going to be full arrows. Okay, but again, when it's a triangle, it's just an arrow that's still there. Okay, now, so again, a trapezoid only has 1 set of parallel sides. Maybe you write that so we know 1 set of parallel sides, and then a parallelogram. Everything's parallel. It has 2 sets of parallelogram. Okay, parallel means that they never intersect. If you extended those lines forever and ever, never will they cross. Okay, now from a parallelogram, again, it's going to take on all the characteristics from the ones above. So rectangles and rhombuses both are 4-sided shapes, and they also have 2 sets of parallel sides. Okay, in a rectangle, do we agree that that is parallel to that? And the sides are parallel to that? Y'all agree? Okay, again, same thing over here. Just adding those symbols. Okay, but then rectangles and rhombuses have their own unique things. Does anyone know what's unique about either one of them? That isn't necessarily true about parallelograms sometimes. Very good. In a rectangle, they have 4 right angles. And that means that their angles are all 90 degrees. They are all equal, but they all are 90 degrees. So it's got the 2 parallel lines, 2 sets of parallel lines, but then all angles are 90 degrees. That's like the unique fact that they add on to a rectangle. Lana, do you know what's unique about a rhombus, or were you going to say that about the rectangles?
I was going to say that about the rectangle.
Okay, gotcha. Does anyone know what the unique thing about a rhombus is?
Yes.
What?
It's so much more.
Yes, Jackson.
Jackson is square.
It's not a square. Some rhombuses are squares, but that's not. All of the side lengths in a rhombus are the same length. So it's all sides are equal length in a rhombus. So these little symbols mean that they're parallel, but then I can go add like a tick mark. It sometimes gets confusing with all. All right, are y'all good with that? Okay. So then from there, a square takes on the right angles from the square. Sorry, a square takes on the right angles from the rectangle, and then it takes the equal sides from the rhombus, and that's what's unique about the square. Y'all good with that? Okay, maybe you knew those things before, maybe you didn't. Okay, so they all have right angles, and they all have equal lengths. Again, I'm going to use the same amount of tick marks on all of them because they're all the same. Are y'all good with that? Yeah. Okay, I'm not going to put the parallel things on there too, but you could also put the parallel little arrows. Y'all good with that? Oh, what are you good with? Great, moving on. So that's just like a little review, nothing crazy. I'm not really going to test you on that stuff, but I might throw in like a little square symbol to say, oh, this is a right angle. It will show you what kind of shape that is. Okay. The main thing to notice is that like trapezoids has 1 set and parallels has 2 sets of those parallel sides. Okay, that's the big takeaway. Okay, moving on. Now, what we're going to be focusing on today is parallelograms, and parallelograms as well as like rectangles and squares. Okay, so a little fun fact. I'm going to do a little activity. This, I don't know if we can do this in the recording, so I might just pause. You can read through this activity and do it on your own, but I'm going to do it with my class, and again, because it's using it in an excited part, so do that on the video. So we're going to play when I'm done explaining. Wow. All right, so for those of y'all at home, basically what I did is we discovered that if you chop off this triangle, let's see if I can do this. Okay, if I chop that triangle off and move it to this other side, I will now have a parallelogram. Okay, that parallelogram still has the same height as the original rectangle, and it has the same length as well. Whatever I took off right here, I just moved to this side. Okay, so how that's going to tie into today's lesson is this. All right, so the reason why we look at that is let's look at our star chart. So if you're at home, hopefully you have the star chart that your teacher gave to you. We are going to look on the formula side where it has the equation. So everyone turn it over and put your finger on the area of a rectangle or parallelogram. Okay, what does it say for the formula? It says A is equal to BH. Nope, for the rectangle or parallelogram. Okay, it says that A is equal to BH. Okay, so right now that's a lot of different letters, and those are different letters than what y'all saw in elementary school. Because in elementary school, y'all learned what? Y'all said A is equal to L times W, correct? Okay, and what did those letters mean in elementary school? A stood for A stands for area is equal to L and W, length times width. Okay, so again, the final, that's not what it says on my paper. What it says on my paper is A is equal to BH. So let's define those letters. A is still talking about area, but B is talking about the base, and H is talking about the height. It's the same thing, we use different letters. There is a reason why we do that, but I just wanted you to know that it's the same equation. Okay? what's really nice about those two things, again, there's only one formula for rectangles and parallelograms. So let's go. All right, so we're gonna go ahead and practice. Now, us 6th grade math teachers have a certain expectation, and those expectations will be carried through 7th and 8th grade. Okay? There are 3 steps that you have to show on every single area problem, and I'm gonna use a shortcut. I'm gonna use the words FSS or the letters FSS. Okay? I want to have FSS on every single page. So maybe in the top corner or on that front page, wherever you have a blank space, we are gonna talk about what FSS means. Okay? The F in this means the formula. Okay? Every single geometry problem, you need to start with writing the formula for that shape. Half of the trouble that 6th grade students have is they write the wrong formula for the shape. So we always want to start with the right one. Okay? So we see a rectangle, we just copy it straight from the star chart. Again, that star chart is our best friend because it's a cheat sheet you get to use on the star chart. Okay? This first S means to substitute. Substitute. Okay, that means when I have my formula, I'm going to replace the letters with any numbers I'm given. If they give me the base length, if they give me the height, I'm going to replace the letters, again, with those numbers. Lastly, I'm going to solve. Solve. Formula, substitute, solve. That's what I expect to see on every single problem. This is also the best way to get partial. This level loves to give partial because I love to give you as much points as I can. But these are the expectations that I expect. I don't care how easy it is, okay, to do it in your head. This is the easiest way to get points. Because if you write the formula, bam, some points. If you substitute it correct, bam, some points. And then if you solve. Again, this carries on into 7th grade because they want you to always write your formulas, substitute, and solve. It also helps me see, oh, they know the formula, they know what shape it is. Maybe they just got the wrong height. And that's fine, and that's, again, where I can find some partial. Or maybe you did a math error. Again, if you formula and substitute correct and just do a math error, I always give partial for that. And you'll see that hopefully on your test. Okay? So, we have rectangles, we have squares, la-di-da-di-da. Again, in elementary school, y'all use the length times width. In junior high, we have the base times height formula. They're the same things, it's just different letters. Okay? So, let's do an equation. We're just going to solve for the area. So I have this shape right here. What shape is this blue shape? It is a rectangle. So what is the formula for the rectangle? Okay, I need your formula. Go ahead and write it. Formula, substitute, and solve. A equals BH. Next, we're going to substitute. Do we know the base length? What's the base length? 8. And what is the H? H stands for height. Do we know what that height is? 6. So I'm now going to rewrite it. I still don't know my area, but it's base times height. So it's going to be 8 times 6. Okay, do you have to write it like that? No. Okay, y'all can do the 8 times 6 like this. Pick your preference. Y'all good with that? Lastly, we did our formula. We substitute. Now we need to solve. Okay, A is going to be equal to how much? 8 times 6 is 48. We just need to solve. Very good. The last little bit that we will start paying attention to, I haven't really cared up until this point in the school year, is units. Okay, when we do inches times inches, that's going to be inches. My area is going to be square inches. Y'all remember that from elementary school? Inches squared. Okay, if you want to see why it's inches squared, y'all want to see why it's inches squared? Because you're doing inches times inches. It's the same thing times itself. Inches squared. Y'all see that sort of thing? Sure. It's the exponents. Anytime it's times itself, it's going to be inches squared. Okay? Are y'all good with that? Yes. Do number 2. Write the formula, substitute the values, and solve. Raise hand. All right. So someone just pointed out, why is there not a square on our formula chart? Who thinks they might be able to rationalize that or reason with it? Yes.
Because they're all equal?
Not quite.
Is it because square is a rectangle?
Because a square is a rectangle. So could I use the same formula? Yeah. Okay, and that's why I use, and y'all did it. So y'all had A is equal to BH. A is equal to the base times the height, which is 9. And y'all said that A is equal to 81 Inches squared or square inches. Okay, it's the same thing. All squares are rectangles, so you just use that formula. Yes. If you use a equals s squared, totally fine. I tend to not because I always want to use what you see on the star chart. But if you remember that one, go for it. If you use a equals length times width, I will give you credit. I don't care. I just always want to use the one that you're going to see on star because I don't ever want y'all to get to star and be like, what is that? Okay. So let me do another one with you on this one. What kind of shape is that, Jackson? What kind of shape is this one right here? I disagree. What kind of shape is that? It's a rectangle. Kenzie, why do you say it's a rectangle? Because the sides aren't equal. Looks can be deceiving. Okay, so every single problem I start with what?
Formula.
My formula. Class, every time I start with my
Formula.
My formula is A equals B8. Bam, I just got some points. Look at me go. Look at you go. Next, I've done my formula. I then substitute. After formula comes substitute. I don't know my area, but I know my base is 3.9 and my height is 4.2. And now I need to solve. Ready, set, go. Okay. 3.9 times 4.2. Okay, y'all help me out. 9 times 2 is? Here, that 1. 3 times 2 plus 1. 7. When I'm done with the 2, placeholder, very good. 9 times 4. 9 times 4. 36. Carry that 3. 3 times 4 is? Plus the 3 gives me 15. Very good. Add it all up. I get 8. 3. Carry the 1. 6 and 1. Ugh. But there was decimals before. Where did they go? Where? How many times do I move it? 2 times because there's 1, 2 behind. I move it 1, 2. So my answer is 16. It's going to be centimeters squared or square centimeters. Are y'all Gucci with that?
Yes.
Oh, what's the next one, guys?
It's a square.
It is a square and it's got fractions. Okay, do the formula, substitute, and try and see if you can remember how to solve. Ready, set, go. Do the next 2. Ready, set, go. Next 2. Ready, set, go. All right, with me, my formula is. Thank you, ma'am. Substitute. A is equal to.
5 over 6 times 5 over 6.
Very good. To multiply fractions, just go across. Okay. So 5 by 5 is 25. 6 by 6 is 36. My units are
Feet squared.
feet squared. Square feet. That's it. Okay. Just go across. Go across. That one can't be simplified. I didn't ask that. I should have asked that. I can't simplify 25 over 36. So that is my final answer. Okay? All right, let's just do one more because I see a whole number of fractions, so let's just review how to do that. Starting with my F stands for formula. I use A is equal to BH. A is equal to substituted.
2 and 2 over 6 times 4.
Let me use this yellow. Sorry, this is just really hard for you to fix. I don't think that made it any better. Okay, so let's review though real quick. How do I multiply a whole number times a fraction? Texas is going to be part of it. I need to turn 2 and 2/5 into an improper fraction. So we use that TX. Start at the bottom, work your way up. 5 times 2 plus 2, 12. My denominator is 5. Okay, so I have I'm just going to do it down here. A is equal to 12 over 5. How do I turn 4 into a fraction? Put it over 1, so 4 over 1. Okay, now we just multiply across. 12 times 4 is 48 over 5 times 1, 5. Can I simplify that one? In a way I can, in a way I can't. I can turn it into a mixed number. Oh yeah. Okay, how many times can I take 5 out of 48? 9 times, and then I would have 3/5 left over. So my final answer, my area, is equal to 9 3/5 inches squared.
If we forget will we get it wrong?
Forget to do what? Simplify it from this to this, you would definitely get vertical. Because you are doing a vast majority of that problem correct, it's just that last step. I would give you most of your points.
What's the most amount of points?
It's going to be different for each question.
Like the same thing.
It's going to be different. Because a quiz could have, it depends on the number of questions. It always changes. There's no set amount. Okay? All right, so let's keep going. I think for the most part, so those were all rectangles. We also have parallelograms. Okay? For parallelograms, again, it's the same exact formula. They use the same exact thing. So let's look at this together. Again, we're going to use the same strategies. We're going to start with our formula. What is the formula that it says on the star chart for a parallelogram?
A equals BH.
A is equal to BH. Okay, so let's start there. Starting with that formula, I see people who have not written it, they're losing their points.
I'll do it.
Okay, so let's look at the base length. What's wrong with this shape, Miss Lytle?
I'm not gonna line through it.
It's got a line through it. It's got, like, does it have any numbers for you to work with? No, but it does have grid lines. Could I count grid lines? Absolutely. So again, for the base and the height, something that has to be true is that, and you see it over here, in a rectangle, what was the unique thing about a rectangle? They have the parallel sides, but then it has right angles. Okay, that height has to make a right angle. So right here, this is showing the height because from here to here, this is showing the height of that parallelogram. Because this is like slanted, it's hard to count those units, like that sideways units, because you're like, wait, it's weird. So when we find the height of a parallelogram or the base, whatever way you look at it, it has to make that right angle. So that's why they always mark it. Okay, there's a word for it. It has to be perpendicular. Okay, but this height, we can count the units. So starting at the bottom, how tall is this thing? It's count to yourself. Okay, very good. I'm going to label that the height is equal to 8. Okay, now the base length is from one end to the other. It's going to be 6. Very good. So I'm going to label it up here because I've run out of space. I'm going to say that the base is equal to, y'all said 6. Are y'all good with that?
Yeah.
Okay, so let's substitute that in. So I'm going to write that A is equal to
8 times 6.
6 times 8, 8 times 6. I'm not going to be too picky about it. Okay, so that can use it to property again. It's multiplication, doesn't matter. And then let's solve. A is equal to 48. Now for the units, it didn't tell me inches, it didn't tell me feet, it didn't tell me anything. So when it doesn't have it, you put units squared or square units. Whenever it doesn't give it to you, you say square units. Gucci? Okay, let me let y'all try a few on your own. Yes. Because it's saying units squared. You could also, instead of writing units squared, you could say square units if you want to. It's the same thing. Okay, so let's look at this one. Number 1, starting with our formula. My formula for a parallelogram is A is equal to BH. Cameron, what is the base length of this parallelogram? Not just 20. 20.8. 20.8. Uh-oh. Now the height. It gave me 2 different numbers. I have to figure out which one is correct. Ms. Lytle just said that the height needs to make what kind of angle? Right angle. Which of those numbers makes the right angle? 11.7. This is going to be my height. Okay, the reason they have this little thing is to show it from top to bottom, straight from top to bottom. This 13 is a distractor. It's not the height, it's a little more. Okay, so I'm going to use 11.7. Okay, y'all want to multiply this together?
Yeah.
Yeah. Okay. Go ahead. Try it out. All right, I'm going to start working it out while everyone else is. 8 times 7 is 6. 5. 14. Placeholder. 8 times 1 is 8, 0, and 2. I'm done with 2 numbers, so I'm going to put 2, 0. 8 times 1 is 8, 0 times 1 is 0, 2 times 1 is 2. And I need to add, so that's 6, 13, carry that 1, 13, carry that 1, 4, and 2. And class, how many times do I need to move my decimal? 2 times. So my area is equal to 243.36 centimeters squared. Okay? So, let's just talk about a quick vocabulary word. We're going to look at it more tomorrow. When the height makes a right angle with the base, that is called perpendicular. Has anyone heard that word before? Perpendicular. Okay? The word perpendicular just means that it makes a 90-degree angle. The height and the base must be perpendicular. All right, and the last one that I'm going to do is in the number 4. You all ready? Okay. What kind of shape is number 4? It is a parallel. It's a parallelogram. Okay, right? So we start with our formula. What's my formula? A equals BH. Looking at this shape, what's different from the ones that we've done before?
It has the area and not the H.
It gives me the area, but it has the H. It doesn't give me the height. So when I substitute, formula substitute solve, that substitute is going to be different. This one's different because I have the value of A. Okay, so when I substitute, I'm going to substitute A is really what number? 45 is equal to the base is 9, and my height is, I don't know, so I'm going to leave it as 8. Oh. Now, do I know how to solve for H?
Yes.
Yeah, we've solved equations. How do I solve for H? What do I need to do? I need to divide both sides. It's 45 divided by 9. You gotta be careful with that. We need to divide both sides by, nope, by 9, because I would get 8 by itself. Okay, this cancels out. Y'all remember that? And then H is going to be equal to 5. Our units in this case, because it's the height, we're talking about not square inches, but inches. Okay? So this is why we teach you the formula substitute solve, because even when they give you different pieces, you know how to work with it, because y'all done solving equations. Okay? So what I want you to work on, let me see real quick. For right now, the classwork, what you'll work on is what we haven't done. Your actual homework is going to be, I think, that back page. Okay, there's a few word problems, a few shapes, all that kind of stuff. We will check that tomorrow. Thank you.